All right, welcome back. We are asked to find the determinant of this 3 by 3 matrix. However, we are going to find it using two methods. The first one is the cofactor expansion, and the second method is the diagonal method. So let's jump into it. So let's go for cofactor, cofactor expansion, cofactor expansion. So we have, now how do you do cofactor expansion? You bring the first element on the first row, the element on this first row. So we are going to use it to multiply the elements on the second row and third row. You just see how it works. So let's say the matrix A will now be, the first element here is 2. So we now reduce this from 3 by 3 matrix to 2 by 2 matrix. So we now have 2 multiplied by, now since we chose this 2 as our first factor, so everything on this column and on this first row, we are not going to repeat it. So we now choose all these these four remaining elements. So which are going to be 4 and 5, then 2 and 1. Okay. So, and also you need to know that in every matrix 6, the first column is plus, the second column is minus, then the third column also comes with what? With positive. So because of this, we have plus 2. All right. For the first element. Now for the second element, you have negative 1 because of this negative. So it's going to be multiplying this, only this element. So since you are using this element, then every row on that element that is associated to that element and all the column will not be repeated. So we are just going to write these other 4 elements. So we have 0 and 5, 1 and 1, 0, 5, 1, 1. Then the last element on that row is plus 3. So what we are going to do, this column is gone and this row is also gone. So we are going to write 0, 4, 1, 2. 0, 4, 1, and 2. Okay. So like the word said, cofactor. So let's multiply what is inside this matrix. So we have 2 multiplied by 4 multiplied by 1 is 4. Then 5 multiplied by 2 is 10. So minus 10. Okay. So this diagonal, the product of this diagonal minus the product of this diagonal elements. So we now have negative 1. They have 0 multiplied by 1 is 0, minus 5 multiplied by 1 is going to give us 5. They have plus 3. Then 0 multiplied by 2 is going to give you 0. Then minus 4 multiplied by 1 will give us 4. So we now say, so our determinant, I'll write it, determinant of A will now be 4 minus 6. 4 minus 10 is going to give us negative 6. Negative 6 times 2 gives us negative 12. Then we also come here. 0 multiplied by 0 minus 5 will give us negative 5. Negative 5 multiplied by negative 1 will give us plus 5. Now, 0 minus 4 is going to give us negative 4. Negative 4 times 0 will give us negative 12. So the determinant of A will now be minus 12 plus 5 will give us negative 7. Negative 7 minus 12 will give us negative 19. Negative 19. So that is the determinant. That's the determinant of this 3 by 3 matrix. So now let's talk about the diagonal method. So for the diagonal method, I'm going to write the matrix. So we have 2, 1, 3, 0, 4, 5, 1, 2, 1. Okay. So for us to use the diagonal method, we just have to repeat this first and second column on this right hand side. Remember, it's only first and second column. So what will that give us? That will give us 2, 0, 1, 1, 4, 2. All right. So that is what we are going to do. So why do we call it diagonal? So we find the product of these diagonal elements, the product of these diagonal elements, and the product of these diagonal elements. So we find their sum. So we can now say the determinant of A will now be 2 times 4 is 8. 8 times 1 is 8. So you have 8. Then plus 5, 1 multiplied by 5 is 5. 5 multiplied by 1 is still 5. Okay. Then 3 multiplied by 0 is 0. 0 multiplied by 2 is still 0. So we now, of course, you can say plus 0 or you leave it. So let's write it plus 0. Then we now find the difference between this other diagonal. So we have this diagonal 1, 2, and 3. Okay? So this will now be 1 multiplied by 4 is 4. 4 multiplied by 3 is 12. So I have 12. Now I have 2 multiplied by 5 is 10. 10 by 2 is 20. Plus 20. Then 1 multiplied by 0 is 0. 0 multiplied by 1 is still 0. So plus 0, right? So we now say the determinant of A will now be 8 plus 5 is 13. Then minus 12 plus 20 is going to give you 32. So you now have the determinant of A will now be 13 minus 32 will give us negative 19. And that is how to use your diagonal method or your cofactor method expansion to get the determinant of your matrix.